Good day, everyone, and welcome to today's DevOps.com webinar. We're excited you've joined us. Our topic today is application performance management and operational intelligence for Amazon EMR. The webinar today is sponsored by Unravel Data. My name is Mitch Ashley, and I'll serve as your host and moderator. A few housekeeping items. We are recording the webinar, and we will send an email to all attendees with a link to the recording and also the slides. So you can download those there or go to devops.com and also get the slides. Now, our speakers love questions, so we want to make sure that they get plenty of questions from our participants. We have three experts who are excited to have you listen to, hear their conversation, but also, of course, answer your questions. So please join in with that. Last but not least, we are giving away 3 Amazon gift cards. So please stick around to the end of the webinar. We'll announce who our winners are. So let's move on to the topic, application performance management and operational intelligence for Amazon EMR. It's my great pleasure to introduce our first speaker, Jason Beck, and he will introduce the rest of the speakers. Jason, go ahead and take it away.
Yes, hello, good morning, good evening, wherever you may be. I'd like to welcome you to our discussion on simplifying data operations for Amazon EMR. So as Mitch mentioned, I'm Jason Beck. I'm a Senior Director of Product Marketing here at Unravel Data. Today, we are joined by Shashi Raina, who's a Partner Solution Architect at Amazon Web Services, and also by Abha Jain, who's a Senior Director of Product Management at Unravel. So just wanted to quickly go through the agenda that we'll be working through today. So we'll start with an overview of big data processing with Amazon EMR, presented by Shashi. And then I'll go over very quickly an overview of Unravel for Amazon EMR, together with a case study, a short case study on one of our joint customers. And then we'll conclude with a demonstration of our product on Amazon EMR, and we'll take questions at the end. So as I mentioned, we'll start with an overview of big data processing on Amazon EMR. And I'm going to hand it over to Shashi. Shashi?
Yeah, thanks. Thanks, Jason. Let me share it. Okay, good morning, good evening, everyone. My name is Shashi Raina. I'm the Partner Solution Architect with AWS, Amazon Web Services. So I'm going to get started with big data processing with EMR. So organizations that successfully generate business value from the data will outperform their peers. An Aberdeen survey, so organizations who implemented a data lake are outperforming similar companies by 9% in organic revenue growth. These leaders were able to do new types of analytics, like machine learning over new sources like log files, data from quick streams, social media, and internet-connected devices stored in data lake. This helped them to identify and act upon opportunities for business growth faster by attracting and retaining customers, boosting productivity, proactively maintaining devices, and making informed decisions. As you see from the slide, the size and complexity of the data that needs to be analyzed today means that the same technology and approaches that worked in the past don't work anymore. First, the data is growing exponentially with machine-generated data from internet-connected devices, growing 10 times faster than data from business applications. This makes it impractical for customers to purchase and install larger, more powerful hardware each time storage and compute capacity limits are reached, and to move massive amounts of data to a separate analytical systems prior to analyzing it. Secondly, the types of data is changing from traditional operational data that are structured as tables and columns to data being generated by new sources like social media, mobile apps, website, and devices. Customers can no longer constrain their analytics to relational data, but need to store and analyze any type of data, including non-relational data, without defined relationships or schema. Thirdly, as data is generated in real time, customers need to go beyond analyzing historical data to analyzing real-time data. If you look at the slide, you see like the traditionally the analytics was run through a relational data warehouse. It collects data from multiple source systems and produces operational reports. This method of analytics had a few characteristics. It was optimized for relational data sources, difficult to scale. It scaled up to maybe petabytes. Rigid schema design. It required the question to be answered prior to data warehouse design because schema had to be created to know what type of data is loaded into data warehouse. It enabled operational reporting on top of data in the data warehouse, and it had high APEX and CAPEX and OPEX cost. To get the most value from the data, customers need a scalable, secure, and comprehensive data storage and analytics platform. Customers need to be able to securely store data coming from applications and devices in this native format with high availability, durability at low cost, and at any scale. Example, they need a data lake. Customers need to easily access and analyze data in a variety of ways, using the tools and frameworks of their choice in a high performance, cost-effective way without having to move large amounts of data between their storage and analytic systems. And customers need to go beyond insights from operational reporting on historical data to being able to perform machine learning and real-time analytics to accurately predict future outcomes. AWS provides the most comprehensive, secure, scalable, and cost-effective portfolio of services that enable customers to build their data in the cloud and analyze all the data with the broadest set of analytical approaches, including machine learning. As a result, there are some organizations running their data lakes and analytics on AWS than anywhere else with the customers like Netflix, Zillow, Nasdaq, Yelp, iRobot, and Finra trusting AWS to run their analytics workloads. Hadoop can act over a data lake. It has distributed processing with diverse analytics that can solve many different use cases. In a recent study for cloud and big data, Forrester made the comment that the cloud and big data is the future. Amazon EMR is a Apache, Hadoop, and Spark distribution built for cloud that combines the integration and testing rigor of commercial Hadoop distributions with the scale, simplicity, and cost effectiveness of the cloud. It allows you to launch Hadoop and Spark clusters in minutes without needing to do node provisioning, cluster setup, Hadoop configuration, or cluster tuning. EMR has 19 open source projects that are tested and integrated into a single solution designed to work together. Each project is updated in EMR within 30 days of a version release, ensuring you have the latest and greatest from the community without having to spend time to test, certify, and maintain new components. With EMR, you can start small. Example, with a 10-node cluster for just 1,314 per year and 24/7 support at around 1,200 per year, less than 1/30th the cost of the other commercial Hadoop solutions. Hadoop and Spark can handle a broad set of big data use cases, including data lake analytics, log analytics, web indexing, clickstream analysis, real-time analytics, predictive analysis, data transformations, ETL, financial analysis, scientific simulation, and EMR. Is enterprise grade, easy, and lowest cost around there. So in terms of the enterprise grade, Amazon enables you to provision hundreds or thousands of compute instances in minutes. You can also use autoscaling to have EMR automatically scale up your Hadoop and Spark clusters to process data of any size and back down when your data is complete and the job is complete to avoid paying for unused capacity. Amazon EMR processes data stored in S3 data lake, which is designed to deliver 11 nines of durability. Data is automatically distributed across a minimum of 3 physical facilities that are geographically separated within an AWS region. EMR monitors a cluster retry failed tasks, and automatically replaces poorly performing instances. You can monitor your cluster using Amazon CloudWatch to collect and track metrics, log files, set alarms, and automatically react to changes in your clusters. Amazon EMR is pretty easy. It provides multiple levels of security for your Hadoop and Spark clusters. This includes network isolation using VPC, encryption of data, and and data at rest in S3 using keys you can control through KMS, which is AWS Key Management Service. Amazon EMR makes deploying Hadoop easy. You can launch an EMR cluster in minutes. You don't need to worry about data provisioning, cluster setup, Hadoop configuration, or cluster tuning. At any point, if you have over-provisioned resources, you can manually resize a running cluster on demand or set scaling policies for EMR to automatically scale down resources for you. Amazon EMR enables you to provision thousands of compute instances in minutes, and you can scale up and down when you need them. In terms of cost, we want to emphasize that Amazon EC2 reserve instances can help you support around 75%, can reduce your bill by 75%. And if you use EC2 spot instances, you can save your bill up to 90%. So that makes your overall EMR usage very low cost. Cost saving for EMR is not just support costs. There's also savings made in hardware acquisition, personal costs, maintenance costs, etc. For IT pros, their pain point with Hadoop is a management cost of Hadoop clusters, configuration, version upgrades, cluster tuning, and hardware setup. With AWS Business Support, you pay the greater of around $100 per month or 10% of the AWS cost. With AWS cost being around 40 cents per hour, you can have 10 VMs, 24 hours a day, and pay around $35,000 for the year. This means that you will be charged for the support for a 10-node cluster compared to $40,000 per year for other vendors. This makes our support costs around 8 times less than the other costs out there. This is like a slide which talks about some of the customers and partners who are using EMR out there to power their applications and products. EMR has a lot of moving parts for infrastructure to application layer. A native monitoring is provided by AWS, and there are also partners like Unravel Data that provide simple to use and intuitive dashboards that enable end users manage and monitor their stack. I will now invite John from Underworld Data Jason from Underworld Data to talk about company and product.
Great, thanks, Shashi. Thank you for that excellent presentation on Amazon EMR. And just to continue our discussion on simplifying data operations, what I'd like to do at this point is to provide a brief overview of Unravel. So according to a recent study by Dresner Advisory Services, big data adoption is growing phenomenally over the last few years. In fact, it's grown from 17% in 2015 to 59% in 2018. And this is mainly driven by innovative use cases by companies that use big data, such as anti-money laundering, fraud detection, predictive maintenance, etc. So you can see that this adoption and this growth is projected to continue to grow. But in the same study, it's been noted that the ability to manage the data is not keeping pace with the data growth that's happening in the industry. And that's partly due to a lack of proper tools to provide diagnostics on big data itself. So let me provide an example. Okay, so big data applications are complicated. So this is an AWS example. So this is an example of a recommendation engine, and you can see that there are various stages to this data pipeline, served up by many great AWS services. So you have the ingestion stage, you have data processing stages, you have different publishing stages, eventually feeding the end user. So you may have a scenario where you're ingesting data perhaps in batch or in real time through services like Amazon Kinesis, further processed by modern processing engines like Spark on Amazon EMR, which may eventually inform the scoring to other outlets, or perhaps feeding deep learning frameworks like MXNet, or perhaps copied to a data lake in an object store like Amazon S3. So you will have different stages and different publishing options. But the main point here is that there's a lot that could go wrong in this data engineering workflow if you lack the visibility to properly monitor and manage these data pipelines. So I'll give you an example. So let's say my application failed. It could be a Spark application, it could be a MapReduce application, and that's causing my SLAs to slip for my data pipelines. So then you start to get into the diagnostics of, well, is it the code? Is it the cluster? My code is fine. What's wrong with your cluster? And you start to get some finger pointing back and forth between the development team and the operations team of who's at fault here. And there hasn't been an efficient way to properly diagnose exactly what's going on in root cause to settle the question once and for all and provide speedy resolution, right? The investigative process of looking at the logs itself is hugely painful today. And that's why tools like Unravel exist to resolve those issues. So you may ask the question of, well, this is on the cloud. In fact, that's a managed service. Why can't I just increase the capacity by beefing up the strongest instances possible on AWS? Well, you could. That could be a short-term solution, but your costs could quickly run out of control if not managed properly, which defeats the purpose, one of the purposes of going to the cloud in the first place. So these are the problems that Unravel aims to solve, right? So we provide an AI-powered data operations platform that provides seamless performance management for modern data applications, or big data applications, however you'd like to call it. We provide a full stack unified view that's driven by AI-powered remediation that allow you to, in somewhat of a set it and forget it mode, set the thresholds and set your tolerance for failures, and allow you to go about your business providing innovation and application development without having to worry about the management of the cluster itself. And in this process, gathering all the telemetry and dissecting the usage of our customers' clusters, what we've been able to do is provide very accurate cost and resourcing optimization information so that you're able to right size your instances, and as well as provide the proper cluster for your money or your budget. And additionally, what we've been able to do is for customers that are looking to migrate from Hadoop to the cloud, a managed service like Amazon EMR, we have a very rich heritage of open source data platforms. So think of your Hadoop, your Spark, HBase, Kafka, etc. We actually use that intelligence to inform the cluster discovery and the source on-premises estate. And we provide a rich lineage and dependency mapping to what that should look like when you move that estate to the cloud in platforms like Amazon EMR. So we were able to kind of show you a before and after picture to properly manage your instances in the cloud at the cost that you're looking for. So today, Unravel supports Amazon EMR. We have a roadmap, in a roadmap to support Redshift as well as Athena. And I wanted to spend just a few minutes on the differentiators between Unravel as an optimization tool versus other tools or other methodologies that you may be employing. So really the secret to Unravel is the fact that we not only aggregate and collect system level information, let's say for your cloud infrastructure, your CPU utilization, as well as your memory utilization and metrics for containers and such. But we also get into the the data component metrics. So things like execution plans and the metrics that inform things like Spark and Hive and MapReduce, Kafka, etc., to provide a 360-degree view and correlate that information for useful contextual analysis. So we can answer questions like, show me all the jobs that Jason ran in the past month that are inefficient. So I can provide optimization recommendations for them and make them run better. Furthermore, what we've done is use that analysis to allow you to provide a business level context. So you can find out, well, these jobs that are actually informing products that I have for my customers, how can I charge that back to my individual departments that are requesting them? Or how do I find bad actors that actually need to be charged and have to suffer a financial penalty for running inefficient jobs? So I'd like to illustrate this with a case study of a media analytics company that runs Unravel on Amazon EMR. And this is a company that had tens of thousands of clusters, about 70% of them on Spark and 30% of them on Hive and MapReduce on Amazon EMR. And the business model of this company was such that they actually sold their analytics to end customers who are retailers, eventual retailers on the other end. So it was absolutely critical for them to meet service level agreements for their business to profit. And they had a goal of reducing their troubleshooting and mean time to resolution by 40%. So they reached out to Unravel, and we were able to improve their cluster visibility as well as efficiency to help them meet that 40%. And they had a goal of providing that chargeback or usage analysis to their end user customers because they had certain products that were premium in nature and they wanted to charge a premium price. So Unravel actually allowed them to do that, with the eventual goal of allowing the developers to be self-service and optimize their own clusters. So here's another view of the results at this particular customer, and we'll call them MTI. So this customer had a number of inefficient applications. So specifically, Unravel was able to uncover 44,000 events across 22,000 Spark jobs, 38,000 events or opportunities for optimization across 31,000 jobs. And just to point out some of the highlights that they were able to benefit from Unravel, they noticed that there was a whole bunch of Spark jobs that were in the accepted stage. And rather than running to completion, they took hours just in that accepted stage. And we were able to deduce that there was a resource contention problem that were actually blocking thousands of jobs. And additionally, we found similar levels of inefficiency where just simple repartitioning of the data, which is one of the recommendations that we were able to provide using our tool, actually drove a lot of efficiency in their Spark and MapReduce jobs. So overall, and you'll see some of this in the demonstration that Abba will show us in a few minutes, that there are a large amount of CPU and memory resource inefficiencies that we were able to uncover, which just improved the business benefits of Unravel overall. So unfortunately, I can't show you the actual screenshots that inform some of those summaries. But what I could do is the next best thing, which is Alba will show you a demonstration of our Unravel for Amazon EMR product. And hopefully you'll get a sense of the types of analysis and the insights that we're able to provide in our product. So Alba, I'll hand it over to you.
Sounds good. Okay, can everybody see my screen?
Yes.
Okay, great. So hello everybody, thanks Jason. So what you're looking at is the Unravel main screen. What I have done here is that over time, I have connected many EMR clusters to this. Some of these have actually gone, they have been terminated, and yet the data from those will be visible here, and some of them which are still working. So very first thing that you notice on this main screen is what's happening with the resource utilization. Clearly, I'm wasting a lot of money because this cluster is fairly underutilized if you look at the total available and allocated resources. This is a helpful view our customers have found because it tells them that they should probably resize their clusters or run more applications to really make use of the resources in the cloud. On the right-hand side, you see the so-called auto actions from Unravel. So you can set up very, very granular alerts. For example, you can say if an application is running more than X amount of minutes or X hours, then please notify. Or if you find that you have a lot of rogue users in the company who knowingly or unknowingly might be using up a lot of resources, you want to be notified if a user asks for more than X amount of memory, and especially if it's not a particular user who's an expert. The point is you can set very, very granular alerting on using Unravel for your EMR clusters and their usage. On the bottom, you see the inefficiencies that Jason was referring to. Essentially, what we are telling you here is that of all the applications that were run on the cluster, there is something better you can do. And I'll get to that in a little bit as well. Another thing to point out is that in our whole system, we are very, very application centric. So let's say, you're looking at the resource usage in the system and you wanted to correlate it with, hey, there's a little bit of a peak here. What was really going on in the system at the time? You click right there and you can see the list of all the applications which are either running or in pending stage or accepted state at that point in the system. This is yet another thing our customers have found very, very useful because this makes it much, much easier to correlate what's happening from the infrastructure point of view, from the resources availability point of view, and what was really going on in the system in terms of the applications being run. The other thing is that customers find very useful is this so-called Chargeback Showback Report. It basically shows what kind of relative use of resources happening across different application types, across different users, across different queues, and maybe even across some custom things like departments, etc., that you can set using a very simple Python SDK in Unravel. So as you can see here, we are showing you what is the relative use of resources by various departments. Let me do this by user. And what you can see is that it's basically, if I were to sort this, it's showing me all the users who are using up a lot of the memory resources, for example. And then you can even drill down further as a platform owner. You can click on the user. You can see that, oh, well, looks like they're running a lot of Spark applications. Great. And then you can actually get to the list of the exact applications they're running. And if you remember, we started drilling down this because we thought that this user was using a lot of memory. And let's see what Unravel has to say if you click on this application. So let's see what Unravel has to say. And it looks like, well, yeah, there's low utilization of memory resources. So this type of drilling down really helps platform owners and operations folks to actually reach out to the right people and help them optimize their applications in terms of resources used, or maybe even for improving performance by using Unravel. Let's look at the list of all the applications here, right? So this is basically showing you all the applications that have been run for a certain period of time. You can choose to see maybe only Spark or MapReduce or specific Hive applications that you want to see. You may want to look at only successful applications or failed ones. You can filter on various different aspects. And then another thing you notice is there are sort of two icons here. So this icon is actually showing you the alerts that have happened. So for example, this particular application has been alerted, we have notified people about this because they set up some auto action stating that this is too long a yarn application, or there's too much memory being allocated. This tuning fork really talks about the fact that, well, there are tuning suggestions that are available for this application. Let's drill down in one of those applications. So here you can see a particular Spark application in the Unravel simplified UI. Naturally, you can see all the Spark jobs which ran as part of the Spark applications. If you click on this, you can see the various stages. Clicking on the stages, you'll be able to see the timeline. Sometimes this is really helpful in figuring out data skew if there was some correlation between the duration of the time taken and then the shuffle map input as well. And you can also see the Gantt chart. You can see the execution graph. You can see various errors, if there were any, or warnings. You can see every detailed configuration parameter. On this side, you can actually see what is the allocated resources in terms of number of containers, in terms of recores, in terms of memory, and so on. In addition, you can also see very, very granular information about each and every single executor and driver in the system. Now, this is all great, all of this going down to the very tasks job level, the stage level, looking at the timeline, being able to look at all these different values in terms of what's really going on in this particular Spark application, from disk bytes spelled to shuffle bytes written, and so on and so forth. And looking at exactly how much system CPU load was, and so on and so forth. However, this is all great for someone who is an expert in Spark, who can analyze all this and choose to improve their applications. But if you have limited amount of time and you want everybody to be able to self-serve and improve their application, here's what Unravel has to say. So first, in plain English, we explain what are some of the things that could potentially be done better with this application. For example, well, it looks like container resources are underutilized. So we explain this problem, and then out here we also tell you what are some of the things that you could do to improve this. Again, it's talking about low utilization of memory resources. It's also pointing out specifically where there's an opportunity for RDD caching. Now, all or some of these plain English language insights are actually converted into very specific actionable recommendations. So what this screen is saying is that you have a set of these parameters, the current values that you ran the application with, which actually made this application take about 23 minutes, 24 seconds to finish execution. Actually use this set of parameter values. Unravel recommends that you use these instead. So once again, if you notice, this application took about 23 minutes, 24 seconds. And once I use the Unravel recommended parameter values, let's see how much the duration goes down to. So now, once I ran it again with Unravel recommended values, the duration came down to 8 minutes, 33 seconds, which is phenomenal. As you can imagine, in the cloud, this has even more meaning because let's say if you were running ephemeral clusters for every application that you're running, this means that your cluster ran almost somewhere around 3 times less in terms of the time that it was alive for, and you can control your costs better. And obviously, if it runs better, you get your results better, you potentially meet your SLAs better, ensure more reliability for your applications as well. I want to hold down a little bit more on the auto actions that I was talking about. So, as I was saying, you can create very, very granular applications. So for example, you can choose from existing templates or create your own. And let's say I say, long running yarn application. I just want to show you that there are more than 100 different metrics that you can use to set up your auto actions. And our customers have used a whole variety of them based on their specific business needs, right? Another thing that our customers have mentioned, besides being able to use these Unravel recommendations and insights to be able to make their applications run faster, one other continuous theme is that, if applications fail, it takes me a long time to figure out how to, what was the cause of the failure and how to make sure that it runs successfully and doesn't fail. And basically the key to that is that Right now, in absence of a tool like Unravel, what customers need to do is to basically look at lots of metrics and charts of what's going on with the infrastructure, look at RM diagnostics, keep looking at a whole bunch of logs, log into multiple different places to retrieve the logs, go through all of these metrics and graphs, look at different logs to figure out why the application had failed. We are told that our customers spend at times hours and hours in this exercise, which is neither productive nor scalable. So what Unravel has done is we have built out a automated root cause analysis as well. So as you can see, this particular application failed. Let's see how long it takes us to figure out the reason for that. Well, I click right here. I go to this tab called application failure, and there you have it. This is the reason why the application failed, because the containers were killed by yarn. And we are also explaining some of the things that you need to check and figure out and improve the application so that it doesn't fail the next time. In addition to just providing the succinct reason right there, right, very, very clearly and simply so you can improve things, we also pull out all the various errors, warnings, exceptions, etc. We even pull out the important keywords to emphasize that you can drill down right here because all the information is right at your fingertips. We also pull out the interesting logs that may be useful for you to analyze the issue further if there's of interest. And once again, obviously, you have access to all the configuration values and so on as well as the resource allocation details, the actual resource usage details, and so on and so forth. So in case you were interested in drilling down any further than the succinct message that you got about why the application had failed. So I think in a nutshell, this was a quick glimpse into the Unravel product for EMR. It's also pretty easy to set up. You basically set up a VM in an instance in EC2. That's where Unravel is deployed. And then all you need to do is to use the EMR bootstrap to ensure that any given cluster can be monitored by Unravel. So that's what I had for today, and we'd love to take questions from you. Jason, back to you.
Yeah, actually, I have a couple more slides, Abba, then we'll take questions. So as Abba mentioned, just to summarize, so Unravel provides a unified full stack view of your data pipeline from end to end, right? And the advantage of that is that, of course, you quickly find the root cause of your cluster failures or slowdowns and not have to spend hours or days trying to pinpoint exactly where the failure is coming from. We also provide remediation powered by an AI machine learning engine that informs really the recommendations that you should apply. And you're not obligated to apply them, but you certainly have the option to apply them to speed up your data system and to avoid failures and to meet your service level agreements. And that's based on data-driven actions and telemetry that's collected from a system like Amazon EMR. And finally, we give you the ability to set thresholds for your resources, as well as automatic remediation in case you want to, you're pretty familiar with your system and you trust in the actions that you've encountered over and over again, and provide that as a self-healing mechanism for your big data system. So Unravel provides all three of these, and we'd love for you to try out the product on Amazon EMR. It's available on the AWS Marketplace, and we currently have a 14-day free trial, and we're offering $2,000 of AWS credits just for signing up. And this is a limited time offer, so please take advantage of it as soon as possible. But this will allow you to experience the product for yourself. And finally, if you have any questions about Unravel from a technical standpoint or a business standpoint, you can feel free to reach us at hello@unraveldata.com, and we'll get right back to you as soon as possible. So with that, let's go ahead and take a few questions. So I see the first question is, how is Unravel installed on Amazon EMR. And Abba, you mentioned bootstrap actions. So would you mind just maybe delving a little deeper into that?
Yeah, sure. So there are two ways. First thing is you set up an Unravel server. So there are two ways, as Jason mentioned. You can go to the marketplace, you set up the Unravel server. This will be an instance right in your EC2 account. We don't have access to any of your data. It remains with you. Or we can actually help you set up by installing an RPM on an EC2 instance. So once the Unravel server is set up, which is the UI that I was showing you, you'll be able to start seeing the Unravel UI. The next step is to connect as many EMR clusters as you would like to be able to have them be monitored by Unravel. And how you do that is while you create the EMR cluster, you specify a bootstrap script from Unravel, which connects that cluster to Unravel, and it starts getting monitored. So it's a pretty quick process. And as Jason mentioned, you could even give it a quick try from the AWS Marketplace, which would be pretty quick to do.
Thanks, Abba. So the next question is really a comparison of the other APM tools that are out there. So how is Unravel different from other monitoring tools for AWS? Such as AppDynamics or perhaps CloudWatch. Abba, would you mind, I think you've done some analysis on this.
Sure. For those who are interested, we'd be obviously happy to share a more detailed analysis. But I think one thing that must have struck you already is the fact that these traditional systems, they give you a lot of matrix and charts, great data collection, and the matrix and charts are available, but the bottom line is they're available for you to have to interpret and correlate with application logs and so on and so forth. The difference between the main difference at Unravel, the main value that we provide is basically the automated insights and recommendations and root cause analysis that basically correlates all of these matrix and charts and various different logs and all that stuff to analyze, and it's analyzed automatically by Unravel, and you're given the exact specific actionable insights and recommendations into how you can improve your applications, find out root cause very, very quickly. That's in a nutshell. We'll be happy to share a more detailed analysis.
Great, thanks, Abba. And the final question really speaks to platform support. So how does Unravel support on-premises platforms such as Cloudera and Hortonworks? Yes, we absolutely support on-premises platforms. In fact, that's really where we began. Our heritage is in supporting open source platforms for Cloudera and Hortonworks. And this in turn allows us to provide very precise migration intelligence if you're looking to migrate these platforms to a managed service like Amazon EMR. So we'll be happy to discuss that in more detail with you, but we absolutely support the on-premises platforms out there. Okay, so I don't see any other questions in the panel. I think we'll go ahead and wrap up at this point. We're ending a little early, but I will hand it back over to Mitch, and Mitch has a few announcements for you. Mitch?
Thank you, Jason. Thank you very much. And thank you, audience, for your questions, and our speakers for your great talks and responses. Just a reminder, we will send an email to everyone that's been a participant with a link to the recording and to the slides. And also check out our DevOps.com site for future webinars. We also want to announce our Amazon gift card winners. Our 3 winners are Stephen G., Dominic T., and Matt C. The folks here at DevOps.com will reach out to you to get those awards to you. So join me in thanking today's speakers. In addition to Jason, we have Sasha and Abba. Done a wonderful job, interesting topic, and really appreciated you presenting this to us. And of course, we want to thank you, our audience. Your time is super valuable, and we're honored that you would spend close to an hour with us today. And we hope the content's been super useful to you. It's been my pleasure hosting. Have a great day, and everybody be careful out there.
Thank you.